All right, here we are. This is the final congruence proof toolbox. When I say final, we could add more if you want. And this is always upgrading based on what proofs that we face and what we might need to face those proofs. So we're going to start with this and just kind of make sure you have this. And I'm just going to explain everything again real quick. Okay, first we start with our definitions. These are the most common ones. Of course, when we use a definition to explain stuff, make sure that when you use the midpoint, definition midpoint, you're creating two congruent sides. So you might have side AB is congruent to side XY, and then you just put the definition of the midpoint. Segment bisector is just like the midpoint. It does cut a line in half. Angle bisector. It's going to create two angles. Perpendicular, depending on the shape, will create 1 to 4 right angles. And oftentimes, we can't just stop at creating right angles. Either we're going to use right angles to prove a right triangle, or we're going to use the right angle theorem later. And I'll go over that. And congruency, if you are forced to change the problem into algebra, or from algebra back to geometry, you can use a congruency, definition of congruency. In some forms, it'll be the definition of congruent segments or the definition of congruent angles. But for our purposes, if we need to do this, we're just going to use the definition of congruency or congruence. All right. All right, moving on to theorems and postulates. Okay. So right angle congruence theorem, if we need two right angles to be congruent for, like a side angle side or a angle side angle, we might have to state that. So this could come after perpendicular. When you create right angles, then you have to do the definition of perpendicular. You might have to use a right angle congruence theorem after that to prove that those two angles are congruent. Of course, the addition postulate, anytime you have to add two segments together, to equal a full side of a triangle, you might have to use the addition postulate. Parallel lines create two congruent angles. With alternate interior angle theorem or corresponding angle theorem, that's usually what you use. Alternate is most common. Sometimes corresponding works when it's kind of a side-by-side triangle. Okay, vertical angle theorem we use a lot. Okay, vertical angle theorem, basically if you see something like that, you got that little X in the middle, you're going to use the vertical angle theorem to prove those two angles congruent. And here we go. We're running out of room here. So reflexive property we use a lot. This is the time that we might use the reflexive property to prove that that angle equals itself, kind of in this kind of shape where the two triangles kind of merge and they share that angle. We also use a reflexive property right here where we have two triangles that are touching each other and sharing a line. Those are two different ways to do it. They're basically the same way, but there's several different ways you can draw your triangles, but basically one side of each triangle is going to be shared. Now finishers, when we plan our proofs, we're going to start by looking how do we want to finish, how do we want to complete this. Of course we got side, 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 angle, side, HL, but I don't like HL like that because some people look at that as two things. So I go ahead and just add and I'll add a little this because I like some color. I usually call it HL right triangle, or and that way you know that you have to prove that the two hypotenuses are congruent, the two legs are congruent, and they're both right triangles. Okay. So moving down, we got ASA, angle side angle, and angle angle side. Remember, and we'll draw a little something on that. Remember the difference between the two of that. Okay, so angle angle side would be angle, angle, and then you would pick a different side like this, a side not in between the two angles. Angle angle side would be a lot like this. Where we would have an angle, and then of course the side would be in between those two angles right here. Okay, so just remember the difference between that. All right, and the last finisher, and actually this is a super finisher, because we're going to have either side, side angle side, HL, ASA, AAS. Once we have two triangles congruent, sometimes it asks for a part of a triangle to be congruent. And that's when we use the CP-CTC theorem. That's congruent parts, corresponding parts of congruent triangles are congruent. And so once I prove two triangles are congruent, yay. And I want this side to be congruent to this side. If these two triangles are congruent, CP-CTC will say that these sides are congruent. So that's basically our toolbox. This is everything you're really going to need for the upcoming test. I'll let you know, obviously, depending on what year you're watching this, I'll let you know when your upcoming test is. All right, see ya.